In other words, have those additional members be on a different disk in case we have media failure. So this is what we would like to have. Okay, so let me show you how to do that. So we go ahead and alter database, add log file member, give the full path of where that file is going to be. The directory already has to exist, otherwise you'll get an error. On Windows it's not case sensitive, on Unix and Linux it is. And then you specify which group you're adding it to. Good, database altered. We'll do the same thing with group 2 and to group 3. So now I reissue this statement. We're looking at our group members and their status. Now these new files here are invalid. It just means that Oracle can't access it now. What it means is we need to clear the log files. We need to make it ready for Oracle. One way of clearing the log files is to issue the alter system switch log file. What that does is it makes the current log file now be the next log file. So it clears it out. And so I issued this statement 3 times because we've got 3 redo log groups. If you want to add a completely new redo log group, then you're going to once again alter database, add log file. You can also explicitly mention a group number. If you don't, then it will just go to the next group, available group number, and then a comma-separated list of files. You also have to specify the size of this group. Now we didn't have to do that earlier because there was already a size mentioned for the original log file in that group. And sometimes it takes a while. There we go. And you can even drop groups just like this. So since these log files are always written to in a circular fashion, you always have to have at least 2 groups. So in our nugget covering recovery, we're going to talk more about these redo log files and what role they play in recovery. You're also going to have undo table spaces, which are used for rolling back information in case you deleted or updated some data you didn't want to. Well, that undo table space will have corresponding undo data files, and those will have a DBF extension, so it's treated essentially like a data file. When you're starting up the database, you're going to have either a server parameter file, we call that an SP file, or you'll have an old style initialization file. Now, the SP file came about in Oracle 9i, but in 9i and 10g, you have your choice of using one or the other. And we have a whole nugget discussing what the differences are between those. I really do prefer using SP files. So let's take a look at where ours is. If you type in show parameter SP file, it's going to show you the full path of where your server parameter file is. Now, if you're using the old style initialization file, then this will show up as blank, and you'll have to look under the Oracle Home directory for the initialization file. Let me show you where that might be. We look under the DBS directory, and what Oracle does upon startup is it first of all looks for a file called spfile, then the Oracle SID.ora. If that file doesn't exist, then it looks for spfile.ora. If that doesn't exist, then it looks for init, and then the orcl.ora. And if that doesn't exist, then your instance doesn't start up, and you'll get a nice little error message. Just to show you another example, let's assume that our Oracle SID is XYZ. So upon startup, Oracle looks in that directory for spfile xyz.ora. Oh, it's not there. Okay, go on to the next one. spfile.ora, not there. Ah, maybe we have an init xyz.ora. It will use that one. One of my favorite files is the alert log. That tells us about major events on the database. For example, when we start up, when we shut down, when log switches occur, when we accidentally fat finger a command, ooh, all that evidence goes in the alert log. Now, on a more fine-grained level, we have trace files, and that's used on the session level if somebody did something wrong within a session. All those files are going to be in dump directories. Let me show you where those are. Background dump dest is where our alert log is going to be. So make a note of where this is. So here are all the files in that directory. See my alert orcl.log. That orcl, that's always going to be the SID. That alert log is a text file, so let's go ahead and open it up. These can get really, really large. I make it a practice to back it up to a file every 24 hours on really active databases. I can make naming conventions like have the date in the data file name. Notice also that I'm at the end of this alert log, and it shows us all the activity that we did on our redo logs. Control files, they have a .ctl extension. These are the files that are read by the instance when the database is starting up or when it's getting into the mount mode, and we'll talk about the different modes in another nugget. The control files contain information about the physical structure of the database. For example, where the different data files are, where the redo log files are. So when your database is trying to start up and the information in the control files does not correspond to the actual structure, physical structure on the OS level, then you've got a problem and your database is not going to open up. Let's look at our data dictionary view called $$ control file. If you do select name from that, it shows us where our control files are. Now, the optimal situation is where you have 3 control files at least on different disks. Now, I didn't do that on my machine because I only have 1 disk, but I am multiplexing it. Just multiplexing means you've got different copies. These control files are exact copies of each other. They have the same size, and we just have copies in case one of them fails. Now, if we've got media failure for some reason on one of the disks, then Oracle will eventually come to a screeching halt and let you know that there's a problem with the control file, and it will tell you which one is the problem. And then at that point, you would copy the good control file to the bad control file and figure out what in the world is wrong with your media and get it fixed. And then last we have backup files. Now that's just a conglomeration of things that you want to save in case everything gets hosed on your system. Oftentimes, if you've got a lot of data files, you might tar up those backup files. You can also compress them, and we'll talk more about backup and recovery in another nugget. The logical structures. How is our data logically organized in the table space? Now, when we talk about logical structures, we're talking about structures that can only be queried from the database. We can dig into our data dictionary and find out all sorts of interesting information. Let's pay attention to the stuff in blue first of all. The largest logical storage structure is what we call a table space. Every single database object is going to reside inside of a table space. Now there's 2 special table spaces that are going to exist on every single database, at least 10G database, and that is the system table space and the sysaux table space. Now the system table space has been around forever, since the very beginning of Oracle, and this is used for data dictionary and metadata information. For example, it stores information about the structure of your whole database. And then there's the sysaux table space used for auxiliary purpose. Now in previous versions of Oracle, in 9i and earlier, we pretty much just combined sysaux and system all into the system table space. Now a really good thing to do as a DBA is to make sure that your regular users do not store their objects in the system table space or the sysaux table space, because those are supposed to be reserved for special purposes. Typically you'll have a users table space. Really you can call your table spaces anything you want to. You can have hundreds of table spaces. Just try to organize your data into logical units, into logical table spaces. You're also going to have an undo table space. That's going to be used for storing the before image information about your data. So in case you need to perform a rollback, it's there. The temp table space is used for sorting data in case we don't have enough memory to do the sort. Now performing sorts on disk is a really expensive operation. Ultimately you do want to have enough memory to perform your sorts, but it's there just in case. Like I mentioned, every single object in the database will be contained inside of a table space, and only inside of one table space, unless you're performing partitioning. Then those different partitions can go in different table spaces. Okay, so let's look at this users table space. Here we've got a person table segment. So a segment is the next smallest logical unit. Looks like I also have an emp table segment. If my person has a primary key, well, we can have index segments as well. We can have table segments, index segments, temporary segments. It is possible for temporary segments to be not only in the temporary table space, but also in regular table spaces. For example, if you're rebuilding an index. We'll talk more about that later in our index nugget. Now let's say that you own 100 different tables in your schema. All of the tables in your schema do not have to belong inside of the same table space. They can be scattered among these different table spaces. So when you create a table or an index or any of those objects, it will initially be given a chunk of space called a segment. And then once that data gets filled up in the segment, Oracle is going to allocate another chunk of area, and we call that an extent. Okay, so I'm going to draw a little rectangle here. Okay, so here we have our person table extent. Notice that it's not connected to this segment because there might be gaps. There might be some fragmentation going on. Once this extent gets filled up, then of course Oracle will allocate more and more extents. And you can specify a max number of extents if you want to. You can specify information such as, well, how large is my original segment going to be? How large is my next extent going to be? And so on. The definition of an extent is several contiguous database blocks. Okay, so I'm putting lines here to represent the different database blocks. So a database block is the smallest logical unit. Now, a database block does not map exactly to an operating system block, but it will be a multiple of the OS block size. In a later segment, I'm going to show you how to manage your table spaces, how to create one, how to modify it, how to drop it, even how to create the objects with specific table space parameters. Let's put this all together now. Let's assume that I want to tap into a database and I'm using SQL+. So that's my user process. It's the client. So I'm right over here. Let's also assume that I'm in a dedicated server environment. So each user process has its own server process. So we'll communicate here with the server process. By the way, that server process was started up by the pmon process. And my server process has its own program global area to store variables. So then I issue a statement, select something from something. It doesn't really matter what it is. That server process is going to attempt to grab the information from the buffer cache. If it can't find what it needs there, then it will actually read the data from the database file down here and then store that data in the buffer cache and return it back to the user process. If I performed any kind of update activity, such as inserting records, updating records, then any changes will be noted in the log buffer, and then during a checkpoint, that data will be written to the redo log by the log writer. If we have our archiving turned on, I'll show you later how to turn it on, then once one of these redo log files gets filled up, it's going to then write to a new archive log. You can end up with quite a few archive logs. For all of those statements, whether that's select, insert, update, delete, whatever, all of those statements are getting parsed, and the hash value, it's a unique identifier for the command, will be stored in the shared pool. So basically, you're caching your commands. So that's really what's going on. Well, I hope this has been informative for you.